Hello. Today we're going to review the process of actually adding hard drive partitions to our existing virtual machine. Okay. For us to do that, we need, of course, an existing instance of Linux. So we're going to do this with your existing instance of Linux that you already have running. In our case, it's going to be Debian, but I know some of you are experimenting with other versions of Linux as well. And if you can get that working, more power to you, of course. But regardless of whichever version of Linux you want to do, there's a couple of steps you need to do. First, you should probably clone this virtual machine. And second, you need to add a second virtual disk to your virtual machine. Now, unfortunately, both of these options are unavailable when our virtual machine is running. I cannot add another SATA drive to my virtual machine. It's unfortunate, but it's the nature of the beast. Also, I cannot clone my virtual machine while it is running. Both of these require powering off the virtual machine. As always, we like to use the ACPI shutdown. It is a fast and elegant way of shutting down our Debian machine. Perfect. Now that our virtual machine is down, we can clone it. I advise the defaults. Default name, default paths, default full clone. Ensure it is a full clone. You want to copy the hard drive as well as the virtual machine settings. And click on clone. If you have a solid state drive, it should be a very quick process. Now you have your clone, go back and choose your original virtual machine and go into the storage settings. Now we can add another disk to our system. And that's what we're going to do. We click on add a disk and it'll let us choose something, and I do have a lot of disks to choose from. As I've told you before, I use this a lot, but I'm going to create a new disk. And like during the installation of Debian, if you click on create, the defaults are fine. Next, next, and next. Alright, VDI, dynamic, and 8 gig are all fine options. So default, 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 and then in your list you will have a non-attached virtual disk available to you. It will probably be highlighted. Just click on choose. Now you can see that you've got two 8 gig drives. Okay, your first drive, you've used about 2 2/3 gigabytes of storage space on it. The second one, even though it's 8 gig in size, has only actually used 2 meg, or basically one cluster on the hard drive. Okay, so that should be good. We've cloned our virtual machine. We've added a second drive to our target virtual machine. We can click on OK. See the results here in our VirtualBox Virtual Machine Manager. We can now start the machine that has 2 drives. Now, for ease of following along, I'm not going to use the terminal. As always, I am going to use PuTTY. And once logged in, because I am changing the file system, I am going to need to log in as root. Let's just go full screen. Okay, perfect. Now, I can show what's mounted in the file system. This shows all the file system mounts that are in place. Your display is probably not going to be as clear as mine, but that's okay. This gives you a full screen view of what's going on in my system. While you're watching this video, you can zoom in and out as necessary. A lot of these are very real world, alright? This is the root of the file system. The rest of these look to be like just a memory-based drives swaps and stuff like that. So really out of scope for our conversation at this point. They don't actually take up space on those virtual disks that we made. They take up space in memory, I believe. Okay? They're all temp file systems, so I'm pretty sure that they're memory-based. But regardless, those are out of scope for our conversation. This is our real disk right here, so that's worthwhile. Next thing we're going to take a look at is the fdisk command. All right, this fdisk-l lists all the disks that we have, in our case virtual disks, and the partitions on them. So fdisk-l, not one, L. And we will see that we have two disks, disk SDB and disk SDA. Disk SDA has the partitions that we set up during our initial install. SDB does not. When you add any partition to any operating system, there's a number of steps you have to engage in. You have to add the disk to the machine, you have to create partitions on that disk, and you have to format those partitions in a file system that the operating system understands. Often this happens instantly, like when you buy a thumb drive and you plug it into a system, it's already got a partition on it, it's already formatted with a FAT32 or something like that file system. When you add a hard drive to a Windows system and you just say add it to Windows, it does all of those steps in the background for you, but it doesn't change the fact that when you add a disk to a computer, you have to set up at least one partition on it, and you have to format that partition in a file system that the operating system understands. And that's what we need to do next. We need to create partitions on our new disk, and we need to format them. Let's do that now. So the first thing we're going to do is the fdisk command, and with fdisk I want to work on drive SDB. So fdisk space /dev/SDB. All right, the drive, not any of the partitions, just the drive. And then this opens up a tool that allows me to start adding partitions to my device. The M command gives us a list of help options available to us, but basically what we are looking for is, where is it? We want to add new partitions, print the partitions. We use the M. If you mess up, you can use the D to delete a partition as well. The other options are really out of scope at this point. We don't really need those, okay? We need to add a new partition and print to verify our results. That's what we're going to focus on. Once everything is created, we want to write our results to the disk and exit. So those are the three arguments we're really going to use today. First, N for new. He wants to know if it's a primary or an extended partition. Now we've talked about this. We're only going to focus on primary partitions, but using this tool, if we wanted to go beyond the 4 primary partitions, if we wanted to create 6 partitions, for example, we would need to say one of our primary partitions actually needs to be extended, and then we would have 3 partitions we need to create. We could create those other 3 inside of the extended partition as logical partitions. We've talked about this in class. So we don't need that. We are just going to create primary partitions. We're going to create 2. The first one obviously is number 1. Now it wants a start place. It's saying there are sectors on this virtual disk from this sector number 2048 to 16,772,215. All right, those are sector numbers, and we can start here and we can go to anywhere here. Okay, it recommends starting there. The default is the value. If I just hit enter, it has started at the default. Now I can try and divide that in half and say that's my end sector, but it gives me an option of saying plus size in gigabytes. I know I made an 8 gig partition. I want two 4 gig partitions. So I'm going to go plus shift equals plus 4 uppercase G. I'm saying make my first partition 4 gigabytes. Enter. And it says I have created a 4 gig partition number 1 of type Linux. Perfect. Let's do that again for the other partition. We want a new partition. This time the partition number type is primary again. The partition number is 2. The default was fine. And now it recommends starting here. And that's fine. It says start here, end here. Those defaults are fine to me. Starting at that works for me. Ending in that works for me as well. Okay? So it created another partition of type Linux of 4 gig. So when I use the P to print out the partitions for this drive, it lists 2 partitions that I created, SDB1 and SDB2, both of which are 4 gig of type Linux. At this point, I have created the 2 partitions on the drive I added to my system. I can now use W to save and exit. It will write up the changes to my hard drive and everything is in place. Huzzah. So let's review. We've added a hard drive to our system. We had to power it off. We added a hard drive to our system. We powered it back on. We saw the hard drive in the system, but it had no partitions. We then used the fdisk command to create a couple of partitions for it. Perfect. Now we need to format those partitions. We are going to format it in a type of a file system called the extended4 file system. It's the one we used for our root file system when we first installed Debian. So let's take a look at that. We are going to do the mkfs command dot, because it'll take a dot, ext4. That's the file system type. We are going to format. The mkfs is to make a file system, and it takes different types. In this case, it's going to be the extended4 file system. And we need to give it a device name, /dev/sdb1. Dev sdb1 is the partition I want to format into the extended4 file system. Dev sdb1 is the partition I want to format in the extended4 file system. And just like when you type in the format command in a DOS window, it will format it and it'll give you a results telling you everything that it has done. Perfect. I want to do the same thing for SDB2. Now I could type it again, or I can hit the up arrow, the cursor key on my keyboard, hit the backspace, and change that to a 2, and enter. Perfect. So now I have formatted both of my partitions to the extended4 file system. Now what I need to do is to add them to my instance of Linux. Okay, now that you have created your partitions and formatted them, we want to add them to our file system. Now, if you recall our earlier conversation, there are no different drive letters. When you add new partitions to Windows, you can add it as a subdirectory like we're going to do here in Linux, but normally when you add a new drive to Windows, when you plug in a USB, when you add, I apologize for the pings, when you add a thumb drive or a CD-ROM to Windows, it gets a drive letter. That's not what happens in Linux. In Linux, everything is part of the root of the file system, single file system, so when we add other partitions or other network shares or thumb drives or CD-ROMs, they become subdirectories in our file system. And that's what we're going to do here. Okay? So, the first thing I need is a point in my file system, a directory where I can add my new share. It can be anywhere, but as we talked about when we looked at the file system, I prefer to use the mount directory off of the root. If I do an ls off of the root of the file system, you will see there is a directory called mount. That's where I like to put extra file systems that get added to my instances of Unix. So that's where I am going to add this new partition, one of the partitions I just created here. I'm going to give myself SDB, actually I'm going to use SDB2 for this one. I'm going to add SDB2 to a subdirectory in mount. So first thing, let's take a look at the contents of the mount folder. There's nothing in there, so there's no subdirectories in mount. I'm going to create a directory there. mkdir mnt share. Let's just call it share so it follows the notes. So I have now a directory in my mount directory called share. I can now add SDB2 to that directory. I can use this as what we call a mount point in our file system for this partition. Let's do that with the mount command. I'm going to mount the device. I'm mounting the device, which in this case is a partition, at a place in the file system, at the mount point I just created. Perfect. Now, when I type in the mount command without arguments, it will list everything I have mounted, including my new mount point. Okay? So anytime I change into mount share, I am now on a completely different partition. Even though all I did was change directories, I am now in a completely different partition. Okay? Now, the problem is if I reboot, it loses that information. If I want to make it permanent, what I have to do is to modify a text file. Okay? That text file is the etc fstab. etc/fstab, file system table. It's basically a text file that tells the operating system what partitions to mount at boot up and where. And that's what we're going to do. Okay? So at this point, we're just going to type in nano etc fstab, and it should create, or it should allow me to open up and create some permanence to this in my file system. Okay. This is, oh, my apologies. The nano, for those of you who missed the lecture, is a text editor that we use to modify text files. We will also take a look at Vi in future classes, but we're going to start with nano. The etc or etc directory is where a lot of the config files for the operating system and a lot of the server processes exist. If you're looking for a config for one of your server processes or for the operating system itself, it's probably in the etc, or as others call it, the etc directory. The file we are looking for is the file system table. So I say nano /etc/fstab, and that opens up the fstab text file in the text editor nano. These down here allow us to manage the tool. All right. For example, Control O writes out or saves our file. Control X allows us to exit. Okay. And because it is a system file, we have to open it up as root. I want to get out, I'm going to do Control X to exit, and if I exit out of being root, I am no longer root, I am now just SJ. And if I try the nano command like that, it comes up with a warning saying, hey, you're trying to modify a file you don't have permissions to. If you see this, you need to go in as root. Again, I apologize for the pings. I've been communicating with you in other classes, and that's why there's so many pings. Okay? So this is telling me that I have opened the file, but without permissions. I need to exit out and become root. SU space dash. enter, and then of course the password you want to use. The password you used when you set it up. So if I try opening up the file with the wrong name, let's say I missed the B in file system table. Alright, I type in FSTA and I missed the B. So if I open up a file and it comes up empty, and I expect stuff to be in that file, but it opens up empty, and more importantly, it says new file, and I expect this to be an existing file, I have probably opened or created a new file, and I haven't opened up the file I was hoping for. So Control X again to exit, and then try again typing in the file name properly. This is why I say over and over again, tab is your friend. Alright, you hit the tab key, it will autocomplete your text, and you are less likely to have a typo. Always use the tab key as much as possible. Alright, if you hit tab and it doesn't do anything, hit it a second time and it'll start saying, well, there's a lot, do you want to list everything, right? So I'm going to say no, and I'm going to say F, oh, you want the file system table file. That's what I want. Perfect. So this is the system that we use for adding file systems to our environment. It has a file system, which is our partition. It has a mount point. It has a type. It has an options. It has dump and pass. These are things used for how it mounts it. These two here are out of scope. We're just going to use the defaults that is used everywhere else. The options, we're just going to use, I apologize for that. We're just going to use the mount point type and options, and it's going to be default, okay, as we see. Where is it? Well, we're just going to use default. Okay, so I'm going to show you that right here. So I'm going to go down to the line. I'm going to create a line just above this last line. I'm going to say I want this ahead of my CD-ROM, my optical media. So the device I'm going to use is dev, as I said earlier, SDB2. Alright, tab. It is a tab delimited file. So I had a tab between one column and the next. Don't use spaces, use the tab key. / mount share. Alright, the file system is the partition, dev SDB2. The mount point is where in the file system, the directory that we want to mount to. It is there. Tab. The type we are going to use is the type we formatted it as, an ext4 file system. Perfect. Any options? We can just use defaults. That should be fine. The default options should be fine. Tab, and we are going to do 0 and 2. All right. Those again are just system settings that make it possible for us to make it possible for the operating system to load the file system properly. It should try a couple of times, and then if it fails, it'll bring you into maintenance mode, where you can actually go in and fix any problems you have, which sometimes happens. Okay, so dev SDB2, and this is slide 16 of the presentation, adding partitions to a Linux file, adding partitions to Linux. So this is all in your notes as well. Okay, Control O to write out. Is going to prompt the file name. The file name should be fine. Do not change the file name. And then Control X to exit, just like that. If you want to do a sanity check, you can always view a file. You can do cat etc fstab, tab is your friend, and it shows our edit right there. Perfect. We should now have a functioning system. At this point, you can type in reboot, and it will reboot your system. Now I'm using the remote connection tool PuTTY, so this is going to cause problems for me, but I will get it back up and running in a sec. Here's my instance of Debian, going through the reboot process, and if there's any problems, it will let me know right away. Alright, if it has problems finding the partitions, it will decry it right here. If you have that problem, let me know, let your instructor know, and we'll go over it together. But now that it is back up and running, I should be able to go back and restart the session. Yeah, perfect. Perfect, and now I'm back in, and when I type in the mount command, there is the device that I just added, and it survived rebooting. So now it's available to me again. Perfect. That was the second partition we created. Let's take a look at using that first partition. Alright, again, I need to be root. I tried the fdisk command. It wouldn't let me because I wasn't logged in as root. Now that I am in as root, I can list the partitions. So, SDA, there are the partitions. SDB, there are the partitions. I've allocated SDB2. Now let's take a look at SDB1. If you recall, when we were setting up Linux, I told you sometimes systems people will create a separate device, actually a separate drive, a completely separate hard drive for the home directory for their users. That way, if something happens to the operating system and you have to reinstall it, you don't have to worry about losing the contents of the individual users' home directories. By taking a look at the directory home, you will see that, with the exception of root, there is a subdirectory for each user in your system. Okay? If I do add user 1, it will go through the process. You can just hit enter on that. It will go through and create another user. Alright, so now when I do an ls-l of home, each user in the system has a directory in the home directory. Each user has a directory in the home directory. If something happens to the overall hard drive, the overall operating system, it might take the contents of those user files as well. One of the ways to mitigate against that is to have this go to a completely separate drive. Now, we're not going to do that. We're not going to use a completely separate drive. Well, I guess we kind of are. You know what? Because the operating system is on SDA, specifically SDA1. This is going to be SDB1, so it's a completely separate drive and a completely separate partition. In reality, they're just files on our Windows machine, but for argument's sake, let's say that we're going to create a completely separate drive and partition for our users. We've already got it. We've already created the partition up here. Where is it? SDB1. Now what we need to do is to migrate our users over to that home directory. Okay? We're going to do that by moving. First, we need to move the home directory for our users to a new place. We take a look at the root of the file system. There is a directory called home. I'm going to put something else there, so I want to move this. I want to back it up. So I'm going to say mv to move. Remember, move will move one file, and directories are files, from one location to another. It can also be used for renaming as well. So I'm going to rename home to home.old. I'm going to make a backup. I'm actually going to rename it so that I have a backup so I don't destroy it. Alright, so now when I do an ls-l, there is my home directory. Okay, Linux expects a directory called home off the root. So I'm going to make a directory called home. So there's the directory where everything should be. There's the contents of my old. All-right. So I've got a point where I can mount SDB1. I've also got the contents of before. So before I copy it over, I actually have to mount the new partition, and then I can copy over the contents of this into that. So let's see what that looks like. I'm going to use the mount command again, dev sdb1. I'm going to mount it to home, just like that. So now when I do the mount command, it shows me that SDB1 is mounted on home. So anything I put in home now goes to a completely different partition on a completely different virtual disk. Perfect. Now what I need to do is copy everything in my old directory into my new partition. We do that with the cp command, and as I said, dash in our last class together, the -p to keep permissions, R to do it recursively. I want to copy everything in this directory over to this directory recursively, and I want to maintain permissions. Okay? I want to copy home.old star everything. Remember, the wildcard is everything, right? I want everything, including recursively, in home.old. I want to copy that over to home. Okay? So when I hit enter, looks good. If I do an ls-al of home, I have the user's stuff still belonged to the different users. Okay, this looks very promising. All right. Now I want some persistence. All right, I want this to survive rebooting, because if I reboot now, none of this is going to work. It's going to be an empty directory, and user SJ or user 1 will not be able to log into the system. Okay, so we need to make this persistent again by modifying the file system table file. Let's do that again as root as we did before. nano /etc/fstab, just like that. Down here we have our entry for SDB2 for symmetry. Let's put an entry above that for SDB1. Tab home. Remember, that's where we mounted that new partition. Home. ext4, it's an extended 4 file system. Again, defaults are fine. Dump is 0. Pass is 2. Just like we did with the mount share with SDB2, we're doing with home on SDB1. Okay, Control O to write out, enter for the file name, Control X to exit. And again, we want to test this. Again, I've lost my connection because I'm using PuTTY. We'll be setting up PuTTY probably our next class is to set up network functionality. I don't want to say next week, but our next class will be setting up network functionality. So the next module will be setting up PuTTY together, and you'll be able to use this tool as well. After it has rebooted, I can then restart the session in my PuTTY. Looks good. The fact that I was able to log into my directory in home and see all of my files from before, all the things that we were playing with in our earlier classes, tells me that I was able to mount SDB1 successfully on the extended 4 file system. Okay, that's it. That's what you need to do for this part of the competency. All right, we will be looking at setting up the network functionality in our next competency, but for this part of the competency, that's what you need to do. All right.